Dorian, what we're going to do now is put everything together, okay? So it says this, a force of one, blah, 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 blah. Read the question, and I'm going to give you a hint to see if you can spot it. There is a two-word phrase that is the key to doing this question that tells you a whole bunch of information in this question. Can anybody spot what that two-word important phrase that we're going to underline is? Steady speed. All of us underline that. Why is that so important? What does steady speed tell us? As a number, what's the acceleration? Write that down over here, which means winner minus loser is going to be equal to 0. In fact, it means it's a tie. Newton's first. Forces are, I'm looking for a word that begins with letter B. They're all balanced. All that information is contained there. You with me so far, Kyle? All right. Kyle, I'm going to pick on you. We're going to do this together. Kyle, what does part A want me to find? Force of friction. I don't want you to write this down. Just look up. I'm going to show you, Dorian, how my brain would approach this. What does this question want me to find, Kyle? So my brain would say, well, okay, don't write this down. Friction equals mu times the normal force. Don't write that down. Now I would go looking for mu. Another word for mu is the coefficient of friction. But as I'm scanning through the question, I don't see a coefficient of friction in what they gave me. In fact, Kyle, what does B want me to find? If I don't know this, I can't use that to find friction. So even though my brain went there first, Zach, and absolutely should, my brain would then erase that and say, gotta try something else, and now I'll say, pick your pencils up, here we go. Okay. Any suggestions on what I might try now? By the way, this question here is probably a B+ level question. This is good and challenging. What would make it an A level question if I had a couple of more forces, or if it wasn't a steady speed? Suggestions. What's this a job for? Yeah. There's the box. Kyle, what are the forces acting on this box? Get the obvious one. Gravity. Is this box sinking to the ground like quicksand or flying into like a Superman? The question certainly doesn't seem to suggest so. Are there any other vertical forces mentioned in this question? Does it say somebody is lifting up or pushing down? Nope. So forces are balanced, and not only are forces balanced, I'm pretty sure the normal force is the same size as gravity. You okay there? What other forces are acting on this question? Well, that 120, we're pulling or pushing this box along. You know what? Let's decide that this box is being pushed to the right. In fact, I am always, when in doubt page, going to have things pushing to the right, just so all of our diagrams look the same. So I'm going to put a force pointing to the right. What force is that? What did we decide yesterday to call an unknown force that was off the page? Could be a horse, could be a car, could be somebody pulling. We gave it a generic name. Do you remember? Applied force. Let's all call that F, applied. And Kyle, in this case, I know exactly how big that is. How big is the applied force exactly? 120. This diagram, if we stopped right now, must be wrong. And the reason it must be wrong is the two words that we underlined. Kyle, what are the two words we underlined? Which means the forces must be, I'm looking for words being littered, and these are not balanced. There has to be a force pointing to the left. What force is that? Which way is this box sliding? To the right? So what force is pointing to the left? Friction. Gotta be. Oh, and you know what? How big must friction be exactly? I would mark this wrong. I would. I would mark this wrong. I would. I know it's going to be the same length as this line, and I'll eyeball it as long as you're close. Par, I'm fine with that. But if you're obviously way off and it's obvious you didn't notice that they're supposed to be the same, I'm taking a half mark off. So I agree. I'm going to draw the line about that line. There's friction. And what did you just tell me exactly? You told me friction had to be exactly how big? And we've just answered part A. Because what did part A want you to find? There, done. Not using mu times the normal force, using Newton's laws and a free body diagram. Well done. Daniel, what does part B want me to find?
Kinetic friction.
The word in front of that. Word in front of that. This word. Of friction. Coefficient of kinetic friction. Last day I did tell you there was technically two types of friction, but we're just going to pretend there's one. It wants us to find, you know what? Hey, what's mu? I don't know. What's me with you? That's what it wants us to find. Okay? Coefficient of friction, this part you'll have to memorize, is what we call in English the mu in the friction formula. In fact, I think, Dan, now we would write down the friction equation. I think now we would be correct to say friction equals mu times the normal force. What did you say this question wants me to find? Hey, what's mu? I don't know. What's mu with you? See the mu? See the coefficient of friction in the equation? How would I get that by itself? What's the normal force doing to the coefficient of friction? So how do I move it over? Here's yet another equation. This is how you actually calculate the coefficient of friction. Apparently, it's the force of friction divided by the normal force. Do I know the force of friction? Yeah. Part A. How big is the force of friction, Dan? Problem. I don't know the normal force. Oh, but look. At my free body diagram, I know another force the same size as the normal force because apparently not only our horizontal force is balanced, but am I sinking into the ground like quicksand? No. Am I flying into it like Superman? No. Vertically, forces must be balanced. What force must be exactly the same size as mg? As the normal force. I just gave you the punchline. Not force applied, because these are not in the same direction. Huh? I don't know. What did I say? What force must be exactly the same size as the normal force? mg. Because that's in the vertical direction. Okay? Vertical has to cancel out vertical because you're not sinking in the ground like quicksand. Horizontal cancels out horizontal because of that key phrase, Jaden, steady speed. Tells us a lot. Dan, did they tell me the mass? Oh, you know what? Actually, they gave me mg. They told me the force of gravity is 250. They didn't even bother telling me the mass. They just told me the weight. No, now, in newtons. What's mu? I don't know. What's mu with you? What's mu? 0.48?
Yeah.
Is that right? 0.48 what? Is this a force? No. So it's not newtons. What are the units for the coefficient of friction? It's a trick question. There are none. Mu doesn't have any units. And I'll prove it to you. Wouldn't this here be newtons divided by newtons? Wouldn't the newtons cancel? And leave no units behind. Yeah. Okay. Is that all right, Kyle? Is that all right, Daniel? So, by the way, I gave you that chart last day of that table of different coefficients of frictions. Easy way to measure the coefficient of friction of an object is you pull it at a steady speed with a spring scale. You measure the force that you're pulling it. You divide that by the weight. That's the coefficient of friction between those two objects. So I calculate it. Last one. Number 8. A dragster's tires accelerate it from rest. You know what? That's probably important. To a speed of 32 meters per second on a distance of 64 meters. Okay. Bryce, what does A want me to find? Are you real? A wants me to find A? You think I planned it that way? Okay. Now, my first thought was, well, maybe, don't write this down. I could go acceleration equals force divided by mass because we're in force land. But what's B asking me to find?
What's the net?
You know what? If it's asking me to find force, I probably can't use force to find acceleration. In fact, I'll bet you I'll use the acceleration from part A to find the force in part B. So I'm going to fall back on, what did you say they're asking me to find in part A? I'm going to go A equals question mark, and I'm going to start to defic. I'm going to start to list my data. From rest. What's that tell me?
VI.
Yeah, I love the way you said that so casually. VI is 0. Good. Yeah, we should be at that stage. Excellent. What's that 32, Bryce? I agree. What's that 64? I totally agree. Hey, we're looking for an equation that has a VI, a VF, a D, and an A in it. I love the fact Sarah flipped open her green sheet a while ago. And again, some of you may have this memorized, but you don't need to. It's all on your green sheet. Sarah, what is the equation that has an A, a VI, a VF, and a D in it? Oh. She got the A by itself right. It's VF squared equals VI squared VF squared equals VI squared plus 2AD, but you got the A by itself already. You said the VF squared drops down like a domino. There's a VI squared, and it's divided by 2D. I totally agree. It's going to be 32 squared minus 0 squared all over 2 times 64. I think I can do that in my head. 32 squared, one of the 32s will cancel with a 64. That's going to leave me with a 8. Double check me. Yeah? Even, right? 8.0. Bryce, units, it's an acceleration. Yep. Have I sold you on why it's worth memorizing units? It really cuts down on your thinking at the end and during, right? Cool. Aaron, what does B want me to find? And net force, remember I said that means I can go straight to F equals ma. Did they give me the mass? 540. Did they give me the acceleration? Not really, but did I just calculate the acceleration? Well, hey. Which is what? You know what? I can do this in my head as well. It's going to be 4,000 plus 320. Is it 4,320? Yeah. Units, Aaron, it's a force. I agree. That's the net force. That's if we went winner minus loser equals blah, the equals blah would be 4,320. Cool. Zach, what's C want me to find? Okay, don't write this down. Ready? First thing my brain would think is friction equals mu times the normal force. Don't write that down. Because, Zach, what's D want me to find? It wants me to find mu, which means I don't know mu, which means I can't do this method. You know what this is a job for? What would you like me to do? Draw. In fact, in Physics 12, we say DULP, draw a little picture. When in doubt, defic and DULP. This particular picture, we give a special name. The abbreviation is FBD, which stands for?
Free body diagram.
There you go. So you ready? There's the dragster, Zach. What are the forces acting on this dragster? Get the obvious one. Is the dragster sinking into the ground like quicksand or flying into the air like Superman? And the question, I don't see any other vertical forces. They don't mention that like a rope is pulling it up or someone's pushing it down. So I think we can safely say normal force equals mg. They're in balance. Okay. Which way is this dragster accelerating? Let's decide it's going to the right. Just so our pictures all look the same. So there has to be an unbalanced force pointing that way. Yes? What force is that? Now we're going to pause. Last class I had somebody say, Mr. Duke, isn't that the applied force? No. What force makes cars go forwards? Ah! And I smile now because what did the question want me to find?
Force and friction.
And I've got it in my free body diagram. That's a good start. Is there any force pointing backwards? No. Air resistance technically, but we're ignoring air resistance. So that's it. So you ready? See the picture? Who's winning? Friction. Who's losing? It's a trick question. Nobody. There are no losers around me. None of you are losers. So I get winner, meaning no loser, nothing pointing in the opposite direction. What does winner minus loser, even if there is no loser, what does winner minus loser always equal? Psst. In fact, psst. How big is MA?
4,320.
Yeah. Aaron found that for us. Now let's walk through our procedure. Bryce, you said I can find the acceleration from the data that they gave me. This would be race car data from the radar gun. Aaron says, I know the mass of the dragster from the plans of the dragster, so I can figure out my net force. Now, Zach can say, hey, I can even tell you what friction had to be to get Bryce's acceleration. And again, I'm not using this time friction equals mu times the normal force. I think I can safely say, apparently, friction is exactly 4,320 newtons big. It must be. It must be. So if I'm, yeah, wait till the end of this. 5 more minutes. So, Raven, if I'm the pit crew of this dragster, I can now actually figure out what the coefficient of friction on my dragster tires is, and whether it's what the manufacturer told me it was, or whether I got hosed. Because, Evan, what's D want me to find?
Coefficient.
Hey, what's mu? I don't know. What's mu with u? Let's write down the only equation that has a mu in it. Friction equals mu times the normal force. Evan, what's the Fn doing to the mu? Adding, subtracting, multiplying, or dividing? How will I move it over? So if you're telling me, and again, Evan, you can memorize this new equation for mu if you want, but I've just showed you how to derive it. You're telling me it's that, right? And what was the force of friction? We figured it out in part C. What's the normal force? I don't know the normal force. Oh, but look. I know another force that has to be the same size as the normal force. Which one? And now I can even be more specific. 4,320 divided by 540, that's m, times 9.8. I hope we get a fairly high coefficient of friction. I hope. What do we get? Well, this is going to be close to 4,000 divided by 5,000. It's going to be around 0.8, but that's a very rough guess. 0.8 what? 0.82? Yeah? 0.82 what? Units. None. It's actually newtons divided by newtons. They would cancel. No units. Okay. So, Dorian, showing you some thinking outside of the box. We can't just mindlessly, anytime we see friction, say, well, mu times the normal force. I can only do that if they give me the coefficient of friction. But if you give me some information, I can even work my way backwards, figure out what friction has to be, and I can even then figure out what the coefficient of friction has to be. And then I could check whatever the tire manufacturer claimed it was and either say yay. By the way, 0.82 for dragsters really isn't that high. This would be like a high school dragster team or an amateur dragster team, because the tires that have higher coefficients of frictions, they're like, you're looking $4,000 or $5,000 per tire. So, although you only need it on the back two, the front two you really don't care too much. You want some for steering, but you're not that fussy. Go ahead, Raven, hustle back. Example 9, if you wanted an example of what on a test I would consider a B+, A- level question, it's this. What would an A-level question be, Mr. Dewick? Extra forces, or in Physics 12, instead of pulling straight up, we pull up at an angle, which changes things an awful lot. Okay. Sarah, what's this question want me to find? The acceleration. Any suggestions on how I might want to start out, Zach?
Something diagram.
I had such high hopes.
Free body diagram.
Free body diagram. I knew you'd get that. Okay. So, by the way, what makes this question an A- level question? The fact that there's an extra vertical force. I'm telling you right now, Krisha, the normal force is not going to equal mg. The normal force is either going to be bigger or smaller. So I've raised my paranoid game. Let's start out though. Sarah, what are the forces acting on this? Get the obvious one. I totally agree. Is this box sinking to the ground like quicksand? Is it flying here like Superman? So everything up has to equal everything down. Are there other vertical forces in the diagram? Yeah, that 25. See it? So here's the question. When you lift up on something with 25 newtons or whatever, when you lift up on something, what happens to the normal force? What happens to how hard the ground has to push up? Does the ground have to push up harder? Does the normal force get bigger? Or does the ground have to push up less hard? Does the normal force get smaller? Yeah. I'll really exaggerate it so it catches my eye. This normal force is definitely smaller than mg. What else? Well, there is another force they stuck on there, that 45. What am I going to call that 45, that thing that's off the page but pulling this? Typically, I call that the applied force. That's my generic force off the page. Something's pulling it. Is there friction in this question, Sarah? How do I know? That will be how I'll typically signal. I'll put a mu somewhere on the question, or in the instructions, I'll use the word rough ground, pulled over a rough surface. That's my way of saying it's not smooth, better include friction. Which way is this block sliding? To the? So which way is friction pointing? To the? Cool. You okay with that, Catchell? I'm going to argue I haven't done anything new today. I've done more meticulous and tougher today. So everyone, see the free body diagram? Who's winning? Good. So anything that's pointing to the right is going to be winner plus? Is there anything else pointing to the right? Nope. Okay. Who's losing? Anything pointing to the left, which in this case I think is only one force. What does winner minus loser always equal? Sarah, what did you say this question wanted me to get by itself? How? So, are you saying that? Yeah, I'll rewrite that. So A apparently is equal to F applied minus friction all over M, where M is 5.8. I got that right from the picture. Sarah, do I know F applied, the applied force? What? Do I know friction? No. Okay. I'm going to find friction over here because I got room. You can kind of go wherever you need to. Friction, you say, Sarah? I always start whenever I think friction with that, and then I ask, did they give me a mu? Did they give me a coefficient of friction? Can I use this method? Did they give me a mu in the diagram? Oh, okay. So what is mu? Sorry, Sarah, I can't ask that. I have to say, what's mu? I don't know, what's mu with you? What is? What's mu? I don't know the normal force. Oh, but look. I know forces that can help me figure out the normal force because is this box sinking into the ground like quicksand? Is it flying into the air like Superman? Then forces are balanced. Or if I even want to be more specific, everything pointing up has to equal everything pointing. Can you give me that as an equation? Everything pointing up has to equal Everything pointing down. I'd like to get the normal force by itself. How would I get the normal force by itself? Folks, can I be this lazy? I'm okay if you do that and don't bother rewriting it. To me, you've shown your work, and I'm fine with that. If you want to, Dorian, write the minus 25 on both sides and do it, and you like your math 8, go ahead. But for what it's worth, because, Sarah, what's the normal force equal to? Wherever I see the normal force, what can I write instead? So if I hear you correctly, I can rewrite friction as, what'd you say mu was? And mg minus 25. Conlon, what's g? What's g? 9.8. What's m? 5.8. Good. What do you get? Oh, because I'm going to use this to find the full answer, don't round off. Carry as much as you can. What do you get? Your calculator. Bracket 5.8 times 9.8 minus 25. Do you 11.4624? Okay. Newtons. Put your pencils down for a second and look up. Okay. Some thought experiments. Sarah, how big is the applied force? 45. Supposing when I calculated friction, I got an answer of 50. What would that tell me? This box isn't moving yet because I haven't overcome friction. It doesn't mean friction is 50 right at that moment. It means friction is exactly 45, canceling out the 45, and I have to pull even harder if I'm going to get this box moving. But if you get a friction force bigger than your applied force and you're already at rest, you're staying at rest. What if this was already moving, sliding, and I got a friction force bigger than my applied force? You know what? Friction is the winner, and we're slowing down. Also possible. So there's lots of good thinking here. Now, we didn't get that. We got 11. That one looks weird. We got 11.4624. All right. I think we're almost done. The acceleration, what did you say the applied force was, Sarah? I agree. Minus 11.4624. Of course, you know I'm going to use my answer button. Divided by 5.8. I get an acceleration of 5.782344828 blah 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 blah. No, yeah? Anybody else? Yeah? Okay. For what it's worth, how many sig figs should I go to in my answer? I think 2. So I'm going to call it, if you wrote 6.78, I'd take that. I'm going to go, sorry, 5.78, I'd take that. I'm going to go straight 5.8. Final bit, Sarah, acceleration units. Sarah, what if I completely reversed this question? What if I gave you the acceleration? What if I gave you the acceleration? Come on, there we go. This number. And asked you to find how big the applied force had to be. In this equation right here, how would you get the applied force by itself? Add friction. That's fair game as far as I'm concerned. Ooh! What if I gave you the acceleration and the applied force and asked you to find mu, the coefficient of friction? I'll let you think about that. There's one like that in your homework. I haven't covered everything. What is your homework? All of these, but I want to talk about them a little bit. What's number 1 want you to find? What's mu? I don't know what's mu with you. Hey, there's a 2-word phrase that's the key to doing number 1. Can you see it? Constant speed. So this is similar to one that we did in our notes. Number 2 is asking you to find what force is required to move the box across the floor. It's asking you to find F applied. Do a free body diagram, and when you go winner minus loser, you're going to get F applied by itself. Apparently, there's enough information to get everything else. Number 3 is asking you to find mu, but I'm being nasty. This is tough. I'm asking you in B and C to find mu when I give you an acceleration. In the first one, in A, it's not accelerating, it's at rest. We did one like that. B and C, Parm, I'm kicking it up a notch. This is what I said this is what I meant when I said earlier in class, I'm kind of throwing you into the deep end, and I have no problem if you have questions and ask me. 4 says find the acceleration of a dragster. 5 says find the deceleration of a rollerblader. Number 6 is very similar to the one that we just did with different numbers. Number 7 is really similar to the one that we just did. Except in number 7, instead of lifting up, we're pushing down. That's going to change your normal force somehow. 8's an elevator question. We've done a bunch of those. We'll do a few more. 9 just says find the normal force. 10, here's a tension question. We did tension a couple lessons ago, just to jog your memory. 11 is asking, hey, what's mu? I don't know what's mu with you. 12 is asking you to find the tension in the rope for the parachute decelerating it. 13 says find the acceleration. And 14, you all get to be astronauts. Here's your thought experiment. I'd like you to use your imagination. Connor and Liam are astronauts, and they're working in weightlessness on the International Space Station. Connor takes a box that has a mass of 45 kilograms, and he nudges it across the cargo hold, and because you're in space, it floats along at 2.2 meters per second. Liam decides to stop it with his face. Will that hurt? Or, in weightlessness, will nothing hurt? Let you think about that. Another way to think about this question is, in zero gravity, in weightlessness, can you use a hammer to pound a nail in? Can you use regular tools or not? It's the same kind of physics. I'll talk about this next class. I have a short video to show you, and then I'm going to turn you loose. No, you want to see the video, trust me.